Now that we know the strategy for our classifier and we have the New York Times API key, we have your key specifically, or you have your key, we can now implement our classifier. And in this example, we're implementing that classifier, but what's so special about it is we're going to be able to use a lot of the ideas and methods that we've developed over the past few units. Some examples of those being in this unit, we've looked at string manipulation. We've also looked at regular expressions from previous units. We'll look at things like visualizations, and we'll kind of take a deep dive into using those methods together to develop this classifier. So you already have your New York Times API key. You're going to need that here in just a second, but if you want to read any more about that New York Times API, we're actually going to cover it quite extensively in this particular element, but you can read about it more here as well. So the first thing we're going to do is make sure we have each of these libraries. So I'm going to go ahead and load those guys up. And away we go. There they are. And then the first thing we're going to do here, actually before we go any further, let's remember what our strategy is. And that strategy is going to be, we are going to have a target headline. And that headline, of course, is composed of a lot of words. But we're also going to download a bunch of, or grab from this API, request from this API, a bunch of other articles which have headlines. And we're going to have those pre-labeled. Those will come to us pre-labeled as news or other. And the way we're going to classify our target headline is to look at each word in the headline and find out what percentage of news articles contain that word and what percentage of other articles contain that word. And we'll do that for each word, and then we'll sum up those percentages for the news, sum up those percentages for the other, and whichever one has the highest sum of percentages, we'll classify it as that particular type, as news or other. So that's the big idea. But first, of course, we're going to have to gather all of those articles and gather our target article. We're going to need our New York Times key to do that, among other things. So we're just going to store it into this string constant here called New York Times key. You can call it whatever you like. Now, this New York Times API, we access it through a URL. We don't have an R package for it. It's actually, we just put a lot of parameters in a URL, send that off through a browser, and it will return to us the results of our query. So what we're going to need to get this one, to have this one run, is we need a term. We need a search term. So we're going to focus our search around the Central Park jogger story that came out of New York in April of 1989, and out around April 19th. I'll tell you a little bit more of that here in just a second, but that's where that's our search term. So we're going to look for Central and Park and jogger. And we've got the begin date here of 1989, 4/19, and the end date of 2 years later. So we're going to get 2 years of articles that are related to this search. And we'll see what we're going to do with those in a second. But for right now, they're just strings. So to give a little bit of historical context around this, here is an article. It's not the New York Times, but it's an article that talked about what the Central Park jogger story was all about. And it was a jogger that was running in Central Park that was pretty severely assaulted, and that's what these articles will be related to that we were trying to classify. So I am going to, once again, return to RStudio here, and we're going to build using strc. We're going to build our base URL, our URL call. Notice that it's got this common string, and then we'll insert our term here. And that term is Central Park jogger. We'll see that come through, and then we'll have the begin date, and we stick in the object begin date, the end date, we'll insert that, and we'll have the call for our API key, and we'll insert our API key. So we can see what happens as we go through this line by line, and we have this URL. It puts together this URL, again, using this string concatenation, string C, that we learned before. So I'll go ahead and encourage you to do the same. Copy this URL. It works just like any URL. Kind of come back out here. I'm going to paste this into the text box up here, and I'm going to run it. Again, you can see in here real quick, you can see there's the JSON search. So it's going to return it to us in JSON format with this particular string. And then we've got our begin date. All of this is in one URL. And then we've got our end date, and then we have our API key. So I do that, and it goes and grabs all the data and sends it back. If you look closely on here, it's in JSON format. It's probably a little difficult for us to read, and this isn't all the data. This is just like the first 10 articles or so. We'll see that here in just a second, but it's in a very efficient and easy format to translate data in. Again, hard for us to read in human form, but that's why we have the JSON-like package. So we'll go on, we'll head on back over here to our studio, and we will make that an initial query. So notice I'm using the object name I'm going to send that initial query to is, I'm going to call it initial query, but the JSON-like package from JSON function, I'm going to send it the base URL, which it will then go out, grab the data we just saw, and then it will parse it using the from JSON function. So I'm going to do that. We'll go ahead and run that, and then once we have that that object, we are going to ask that object. It's essentially a data frame, and it's got some attributes, and one of those attributes is the number of hits. That's essentially the number of headlines that we have, or that's the number the number of pages of headlines that we have. It returns it to us in pages, so it doesn't kind of clog up the bandwidth of sending it back over to us. So what this is going to do is I'm going to call this max pages, and I'll kind of tell you why this is a -1 here at the end, but I will divide it up. I'm sorry, yeah, this hits is going to tell us the number of actual articles that it's returning, and we're going to put 10 per page, and I'll tell you why this -1 is here in a second. This is just how it's going to send us the data. So I'll go ahead and look at max pages. So that's about 43 pages. And so there's 430 something articles, actually 440 something articles, but we're going to translate that to us in about 44 pages. And again, why is this -1? Because there is a page 0. So just the way this comes, one of the references page 0. Again, we'll see that here in just a second. But we're going to have a place to store all these pages of articles and headlines. So that's what this is. It's simply just a list, and each element of the list will contain essentially 10 articles that'll be listed as a page. And the way I'm going to read all this in is for I in 0, so it starts at page 0 to max pages. So there'll be 44 total pages here. It's going to go out and say, hey, let's grab this JSON data. We'll have our string. Again, we're going to have the base URL, and then say, hey, I need page 0, then page 1, then page 2, then page 3. So it'll read it all in, because this could be a lot of data by the end of the day. And we're going to turn it into a data frame, and then I'm going to have a nice little message here that lets me know kind of the progress. This is just saying, hey, return this message, retrieving page 0, retrieving page 1, so on and so forth. And then I'm going to put each page in our list, and again, I want to reference the list at 1. Page 0 is going to go into list element 1, page 1 is going to go to list element 2, and finally, we're going to do system sleep 7. And really, the reason I'm going to show you how to do that, because the way that this works, the way it translates and transfers this information over the internet, we don't want to clog it up and have too many requests in too short a time. So if we come back over here, you'll see in these frequently asked questions for the New York Times API, one of them is there an API call limit? So if you click on that, you'll come over here, and we'll say right here, is there an API call limit? Yes, there are 2 rate limits: 4,000 requests per day. So we're not really bumping into that quite yet, and 10 requests per minute. You should sleep 6 seconds between calls. That's key. You should sleep 6 seconds between calls to avoid hitting the per minute rate limit. If you need a higher rate limit, please contact us. So if you leave that, I've hit this limit several times before I found this. So that's why we see on here, I just don't even make it, I've hit the limit on 6 as well. So I just make it 7, and I don't really have a problem with 7. So we're going to go ahead and run this, and we'll see what it does. So I'll go ahead and click that, and we'll see it. It has retrieving page 0, and then it sleeps for 7 seconds. Then retrieving page 1, and retrieving page 2, so on and so forth. So it's gathering all of that data. It's going to do that 43 times, and then it's going to do that 43 times, and then it's going to bind it. We'll see this when we come back. It's going to bind all those pages into one data frame. But as you can see, this is going to take a little time, so I'll let it, again, we'll have to go through 44 pages like this, all the way up to page, quote, 43. So we're going to take a little break and come back, and then we'll finish out putting these together into a data frame, and maybe we'll even look at 1 or 2. So we'll see you when we come back.